Okay, so our notes for 2-1, this is math 7. Which one of these fractions does not belong? So I have 4 fractions here written down on your notes. One of these does not belong. One of these is not the same or is not equal to the other 3. So let's take a look at this. If I'm looking at my first fraction, that says negative 2/3, meaning that that entire number is negative. So this is a negative. If I look at the second option, that says negative 2 divided by 3. Well, we know from our last unit 1 on integer rules, if I have a negative number and I divide it by a positive, does that end me with a negative or a positive? Those are different signs, so that would end with a negative. Option 3 has positive 2 divided by negative 3, which is the same thing as that one right next to it to the left. Just the only difference is that the negative sign is with the 3. But if I have a positive divided by a negative, those are still different signs, and that still results in a negative. Now, let's check out this last one. The difference between these guys, this one here has a negative 2 divided by a negative 3. A negative divided by a negative actually ends up being a positive. So which one doesn't belong? That would be this one. This one is a positive because negative divided by negative is a positive answer. A negative divided by a negative is a positive. Whereas those other 3 options are all negative values. They're all the same. Negative 2/3 is still equal to negative 2 over 3, which is still equal to negative 3 with the 2 on the top. So moral of this story here is that the negative sign can be out in front of the fraction like it is in the first choice, or it could be in the top like it is in the second one, or it can be in the bottom like the third, but it cannot be in both spots. That negative is only either in front of it on the top or on the bottom, not both, because that would turn it into a positive. Okay, now let's check out our definition for irrational numbers. Remember, the definition of a rational number is any number that can be written as a fraction. So rational numbers make sense. They're the opposite of, irrational numbers are the opposite of rational. So if rationals are fractions, irrationals cannot be written as fractions. And the kind of numbers that you're going to look at, that you're going to see that are irrational, are never-ending, keyword here, never-ending, and both of these things need to be true. It needs to be never-ending and non-repeating decimals. So our repeating decimals, like that 0.3 or that 0.6 repeating, those are considered rational numbers. It's non-repeating and never-ending. It's both of those things. So the most famous example of an irrational number is that pi. It's a terrible way to draw pi. Pi is that most famous irrational number. And if you have your calculator, you can go right to your calculator and you can find the pi button. Yours will be a lot easier to find than mine. I can see a pi button on here. This is why you use a real life calculator. Standard scientific. I don't know. Why is there not a pi button? That, ladies and gentlemen, is a bunch of baloney. Oh, it's right there. Duh. I'm being really dumb. Okay, there we go. So notice I hit that pi button, and look at that giant number that popped up. 3.14159265 blah, 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 blah. Notice none of those numbers have a pattern. None of those are repeating like they are in the 0.3 or the 0.6. That is a never-ending and a non-repeating decimal. Now, never-ending, obviously, your calculator can't show you everything because your calculator isn't, infinite. But when it goes to the end of your calculator, like this number is, you can assume that it is a never-ending decimal. Another one of the most famous irrational numbers is what's called the square root of 2. And again, look at this big giant decimal. No pattern here. None of these digits are repeating, and there is a never ending. It keeps going on forever and ever. So examples are like pi, the square root of 2, and let's look at that example. The square root of 2 is equal to 1 point, and I'm just going to do this again so I don't have to relook at it. 1.414213562 ... Never ending and non-repeating for those guys. All right, let's look at the examples in the next video.